have here is a circle. Okay? Shh. We're quiet now. Okay, the area formula for a circle is pi r squared, where r is the radius. Okay, r is the radius of that circle. Now that is different from the circumference of a circle. Okay, circumference is 2 pi r, or pi times the diameter. Okay, so with circumference you can use the diameter. With area of a circle you cannot. Okay, so if you're given the diameter, you have to divide by 2 to get that radius in order to use the area formula. Okay, and the difference between the two, circumference is the distance around the circle. Okay, area is everything within the circle. Okay, a picture, we would have a circle here. Okay, a radius would be half that length there. So you do need to find that radius in order to use this area formula. Okay, next is a triangle. Okay, the area formula for a triangle is base times height divided by 2. Okay, so you're multiplying your base times your height and dividing by 2. Okay, so I can draw a triangle. My picture spot here. Okay, your height. The height of a triangle has to be perpendicular. Okay, so this would be the height. Then the base is that section where your height meets at a perpendicular. So that entire bottom length there would be the base of that triangle. Okay, a parallelogram. Area formula is just base times height. Okay, for our parallelogram here, okay, again the height has to be a perpendicular distance. Okay, so perpendicular, that is the height. Then the base is where your height again meets at that perpendicular. Okay, so at that perpendicular piece, that is the base. Okay, then a rhombus. That area formula is d sub 1 times d sub 2 divided by 2. Okay, those are your diagonals within a rhombus. Okay, so here make a rhombus. It does look like a parallelogram. Okay, except, we are paying attention, please. Except all 4 sides are congruent. Okay, and to find the area, you do need the entire length of that diagonal. Okay, so that length here, that would be d sub 1. Okay, and this entire length here, that would be d sub 2. Okay, so you need the entire length of those diagonals. Extra property with a rhombus, your diagonals are perpendicular. Okay, so they meet at a perpendicular. Okay, next we have a trapezoid. Okay, the area for a trapezoid is your height times both bases added together, then divided by 2. Okay, in a trapezoid, you have one pair of parallel sides. Okay, so one pair of parallel sides, those arrows indicate they're parallel. Those two parallel sides are your bases. Okay, so that would be base sub 1 and base sub 2. Okay, then again, the height has to be that perpendicular distance between the two bases. Okay, next is a kite. A kite's area formula is the same as a rhombus. Okay, so the area would be diagonal 1 times diagonal 2 divided by 2. Like a kite you would fly. Oh. So, okay, here's a kite. Okay, again, you need both diagonals to be multiplied together. So this longer one here I can call diagonal 1, or you could call it diagonal 2, it doesn't matter. Okay, then your second diagonal here, that would have to be diagonal 2. Now, just like with a rhombus, your diagonals are perpendicular to each other. Okay, so these have to be perpendicular. They have to meet at a 90-degree angle. Okay, another one we talked about was a sector. Okay, so that's part of a circle. So we need to take a fraction multiplied by the area of a circle. Okay, that fraction is x over 360 times pi r squared. So we have our area of a circle multiplied by that fraction of that circle. Okay, so in our picture here, okay, we need one piece of that circle. Okay, this x part is the central angle. Okay, so the central angle, the angle that's made up of that sector. Okay, and then r, again, is just your radius. Okay, the last one we went over, I know it's not on here, I'm going to add it in, is a regular polygon. Okay, so regular polygon. That area formula is apothem times perimeter divided by 2. Okay, now, again, a regular polygon is where all of your sides are congruent to each other and all of your angles are congruent to each other. Okay, so it could have a different amount of sides. The one I'm going to draw on here is just going to be a square. Okay, so we're going to draw a square. Again, it doesn't always have to be a square. Okay, so from the center point, you have a radius to a vertice. Okay, that's your radius. Then the apothem, or A, in our area formula is that segment drop down to the side and perpendicular to that side. Okay, so that would be the apothem. P is the perimeter of that polygon. Okay, so adding up all four sides would give you that P value or perimeter to enter into your formula. Okay, so again, A is the apothem and P is the perimeter. Okay, just as a reminder what they are. Okay, and it's the perimeter of the polygon, not the triangle. Okay, so you're not finding the perimeter of this little right triangle you made. You're finding the perimeter of the whole polygon. Okay, so those are the different area formulas that we went over in this chapter. Any questions on my drawings? Any questions on the formulas themselves? Anything you need cleared up in the drawing? Then as you go through your notes or anything like that, if you want to add anything to these pictures to help you out by labeling it or anything like that, write that in. Okay, so this is supposed to help you find each and every area formula. So you don't have to flip through every single page of your notes. Okay, then I do want you to work through the rest of these problems. So with these ones here on the next page, these are kind of like the ones that we did with area of circles, where you have one and you have to subtract the other from that first one to find just the shaded region. Okay, so we are just finding the shaded region for all of these pictures here. So for this first one, number 1, you could find the area of the large square, right? And then subtract the area of the small square from that in order to get just that shaded part. Okay, same thing here. Find the area of the rectangle, find the area of the triangle. Okay, subtract the triangle from the rectangle to find just that shaded region. Okay, so that's what you're doing in that section there. The rest of them I think you'll be able to do. This is not your only review. This is today's review. You have another one tomorrow. Okay, so with the rest of the time, I need you to work through these problems. Use the area formulas from the front page to help you. Okay, ask questions if you have any. But other than that, you can